Hello, welcome to Fast Learn. In this video, you can try a 1-mark question on SHM. In particular, you'll be analyzing a system and deciding whether the system actually performs SHM or not. Throughout this video, we'll be using the standard abbreviation for simple harmonic motion, which is SHM. Now let's take a look at the question. A mass attached to a spring is stretched to point Z. See diagram below. A student suggests that when released, the mass spring system will perform SHM. Are they correct? Justify your answer. Please pause the video here and have a think about this by yourself. When you're done, unpause the video and we'll discuss the solution. Okay, welcome back. Hopefully it's clear to you that given that the spring is stretched, once released, the mass spring system will oscillate about the equilibrium position. The question is though, can these oscillations be said to be SHM or not? Let's take a look at another example first, before we get to answering this. Consider a simple pendulum. If we displace the pendulum by 30 degrees to the vertical and let go, it will oscillate back and forth. However, despite oscillating, the pendulum won't be undergoing SHM. In order for a pendulum to perform SHM to a very good approximation, it needs to be displaced from equilibrium by no more than about 10 degrees. So while SHM implies oscillations, the converse is not true. Oscillations don't necessarily imply SHM. In other words, just because something is oscillating does not necessarily mean that that system is undergoing or performing SHM. So why does the pendulum on the right perform SHM, but not the one on the left? Recall the defining statement of SHM. A is proportional to minus x, where A stands for acceleration and x stands for displacement from equilibrium. This is equivalent to the statement F is proportional to minus x, where F stands for the resultant force, and which is sometimes known as the restoring force. As long as the pendulum is displaced by no more than about 10 degrees, F will be proportional to minus x to a very good approximation, and so the pendulum will perform SHM. On the other hand, if the pendulum gets released at 30 degrees, F will no longer be proportional to minus x, and so while the pendulum will oscillate, it won't perform SHM. Returning to the question, we can see that the force extension graph is a straight line from the origin up to a certain point, known as the limit of proportionality, which is shown as this black point or dot here. In this region, we can say that F is proportional to minus x. Now x, the displacement, you can think of that as being equivalent to extension here, and we need this minus sign here because F and x are vector quantities. And the minus sign just tells us that the force will be in the opposite direction to the displacement. So if the mass was stretched up to a point in this region here, in this straight line region here, then the mass spring system would undergo SHM because F is proportional to minus x. But since the point Z lies outside this region, in a region where F is not proportional to minus x, the release mass spring system will oscillate but won't perform SHM. And just to be clear, the reason why F is not proportional to minus x in this region where Z lies is that beyond the limit of proportionality, so to the right of it, the graph curves and therefore becomes non-linear. The student is therefore incorrect. If you found this video useful, please like it, share it, subscribe to the Fast Learn channel if you haven't already, and leave a comment. I'd love to hear from you. Thank you for listening, and I hope to see you soon.